Hello everyone, my name is Manas Milind and welcome to another session of Learn Maths with Milind. Today we are going to learn integrals of type px plus q upon ax square plus bx plus c or px plus q upon under root ax square plus bx plus c. If you see these kind of expressions in your integration questions for both these types, you have to follow these same three steps. Just to tell you the steps in brief, what we have to do here is we have to replace the px plus q expression with a times d by dx of ax square plus bx plus c plus b. The goal here is to find the values of a and b and put it back in this numerator. To do that, we are going to do the comparing of constant and coefficients, which will help us to get to the value of a and b. Then what we are going to do is we are going to put this back and we are going to perform a split division. That is, whatever the expression is, we will separate this denominator with both the expressions in the numerator, and then we'll form I1 and I2. Let's get started. So I have taken a sample question over here. As I say, the step 1 is replace px plus q, which is nothing but 3x plus 1, by a times differentiation of 2x square minus 2x plus 3 plus b. By the way, this question is also called linear and quadratic form. What is linear? If you have a variable whose maximum power is 1, it's called a linear expression. If you have an expression with a variable with a maximum power of 2, it's called a quadratic expression. Okay, so the first step is to differentiate this. I hope you guys are clear with differentiation. So differentiation of 2x square will become 4x and differentiation of minus 2x will become minus 2. Differentiation of 3 becomes 0 plus b. Left hand side remains as it is. Next step, we are going to write the x terms together. So a times 4x becomes 4ax and we are going to write the constants together. I am writing the plus sign here purposely so that you don't get confused with the minus sign. Now what we have to do is we have to compare constants, or I should rather say constant and coefficient of x. I have explained what does coefficient means in my last video. So coefficient is nothing but the number multiplied with the variable. So if you see here, let me color code this. 3 and 4a have to be equal in order for this expression on the left hand side and the right hand side to be equal. So this implies that 3 is equals to 4a, and this is by comparing the coefficient of x. So what do we get? We get a as 3 by 4. Similarly, to find b, now this is a constant expression and the constant expression on the right hand side is, on the left hand side is 1. So you compare these two, you get 1 is equals to minus 2a plus b. We have already figured out the value of a, so put this value here. We get 1 is equals to minus 3 minus 2, 3 by 4 plus b. You get minus 3 by 2. When you transfer it to the left hand side, you get 1 plus 3 by 2 is equals to b, or b comes out to be 5 by 2. So this completes our step 1 and step 2. We have figured out the values of a and b. Now, one more important step. When you differentiate, call this equation 1. Why are we calling this equation 1? Because we need to replace our expression over here with this expression, and we will also substitute the values of a and b. So let's replace it. The values we have is a is 3 by 4 times this expression. So we are replacing 3x plus 1 with this expression where a is 3 by 4 followed by 4x minus 2 plus b. B is nothing but 5 by 2 whole divided by the quadratic expression, which is 2x square minus 2x plus 3 dx. Now when I say split division means let's call this term as a, let's call this b, and let's call this C. So we can write this as A by C plus B by C. This is called split division. Split division means separate the numerators with the common denominator. So we will get 3 by 4, 4x minus 2 whole divided by, or just divided by, 2x square minus 2x plus 3 dx. I am going to call this I1, and this entire integral will be called as I, plus this will be 5 by 2 divided by 2x square minus 2x plus 3 dx. I am going to call this as I2. So let's solve this one by one. I1, so solving I1. Now remember, this is going to remain same if you have these kind of questions, because we have already differentiated this. That's how we got 4x minus 2. So this is a part of substitution where you have to take the entire denominator as t. So you take this as t, differentiate this, we get 4x minus 2 dx is equals to dt. I hope you guys are clear with substitution. If you are not, I'm going to prepare a video for that also pretty soon. Now replace it. So I1 is, one more important thing, whatever constants are multiplied inside the integral, take them out as soon as possible so that we can clear out the clutter. So 3 by 4, 4x minus 2 dx, this entire thing becomes just dt. So this will become dt divided by, this expression has already been called as t. So we'll get dt by t, which is nothing but 3 by 4 ln mod t, or 3 by 4 ln mod. In substitution, the last step is you replace the value of t. So we'll get 2x square minus 2x plus 3. You can call it plus c1 because we are calling it I1. This will be our I1. Now we have our I1. To find I2, I have already prepared a video where I am telling how to find the integral of quadratic type. Please go check out video number 2. I am directly going to write the answer for this so that you guys can compare once you are done. The answer for I2, once you solve it, you will get will be 5 upon 2 root 5 tan inverse 2x minus 1 upon root 5 plus c2. We are going to call it c2 because we are finding I2. This will be our I2. Once you get all both of these, you go back and put it in equation 2 because we have to write ultimately I as the answer. So we will get I1 plus I2, where you simply copy and paste your values of I1 and I2. 2x square minus 2x plus 3 plus 5 upon 2 root 5 tan inverse 2x minus 1 upon root 5 plus c. Now if you're wondering where did the c1 and c2 go, first of all, provide this cool signature over here that this is your answer, and c is nothing but where c is equals to c1 plus c2. That's it guys, hope you understood this. Please drop a like and comment and subscribe for more videos. I'll be posting more videos pretty soon. Thank you.